We'll get rolling. So this is an IT operations approach to observability. I'm Mike. Feel free to yell at me if you have questions, or just raise your hand and I'll try and answer them that way too. But lots of good discussions so far at the conference. A lot of great hallway talks, as that was mentioned a lot. So always happy to have hallway talks too if you want. So as we think about observability, it's a really complex topic in the sense that it's defined different ways. I was talking with an analyst recently about this, and a good way that he sort of differentiated this is monitoring is when you know you're looking for something. Observability is what you do when you have no idea what you're looking for. So we're going to nuance that a little bit. I use observability to include monitoring. These use cases are going to be more on the monitoring side of we know what we're looking for, and so that's where we're going to start. A lot of you've probably heard about single panes of glass and these things that are just going to answer all our questions, tell us everything we need to know about an environment, and really just make our jobs easier. But at the end of the day, there's a lot of things that we can monitor that are not pertinent or useful. Like, do I need to know the idle percentage of my CPUs most of the time? No. Why would I need a dashboard that tells me that regularly? Because it's probably not useful except in rare circumstances. So that's where we start to get into what are we ultimately trying to get out of these services? We're really trying to answer questions like, is the environment healthy? We're trying to answer things like, is this anomalous activity? Is this something that shouldn't be happening? Is this something that is efficiently being used? Or is this something that we can optimize further and we should invest time and effort to do that? And ultimately, does it even matter? If we can't report on what things are doing, we can't really report on if that thing is valuable in any capacity. So when we think about observability, there's 4 real components that always come up, and that's MELT. So metrics, events, logs, traces. A little bit of context. Metrics, those are the discrete values over time, usually that we like to measure. Events, those are the things that application developers, ourselves, we like to create events and say, this is what's happening in our environment. And those logs are where we're aggregating all those events. Traces, as we get into distributed computing environments, become very critical. So if I'm querying something in system A, and that's ending up processed by database B, and that's going through load balancer Z, I need to know how to correlate that between systems so that I can actually understand where things are happening and where those transactions end up in our systems. That's where traces come into the picture. We won't be diving into all of these today because it's a lot. Observability as a topic has different levels of maturity as well. So there's 3 main levels of maturity I like to usually speak to. The first just being, can we monitor anything? Do we know what we own? Do we know what we should be monitoring? The second level is, can we start to do root cause analysis? So we know we own this thing. We know we should care about it. When something happens, can we do any sort of retrospective and understand why and what happened? And then we get into the conversation of how can we improve this and automate this further? And that's usually like an AI ops maturity level conversation. We'll touch on that a little bit more here in a second too. But MELT ultimately, as a component, is helping us communicate. And ultimately, what MELT is letting us communicate are things like service level indicators. So if you are in either a service management shop or you are in an SRE shop, service level objectives and service level agreements are things that you're communicating to your customers, your employees, your other external business partners that you will support. And your service level indicators are the reality of your objectives. So if we're committing to this outward agreement, ultimately our agreement is setting a goal, our objective, and we need our indicators to tell us what the reality is. Did we meet our objective? Did we exceed our objective? Did we drop our objective? And usually our agreement is going to say, hey, based on how we performed, here's the outcome. So I do an ITSM talk about a lot of this, IT service management, and I like to joke that ITSM and a lot of these concepts are how you do marketing as an IT department. This is how you communicate your value to the organization or your customers. So it's really valuable to think of it as we need to be able to communicate these things and tell people what they can expect of us and what inputs we expect of them. Stealing a concept from security operations is this concept of a control. So a control is generally a discrete thing we have some ability to manage. We can contextualize that into an operational control. So not security focused, but an operational thing that we can manage and control the state of and understand if it's healthy or unhealthy, acceptable or unacceptable. So as we think about an operational control, we can also apply governance, policy to that. We can tell what is acceptable, what is unacceptable. We can define those ranges or those values that we expect. And so there's a lot to unpack there. We'll just scratch the surface, but there's a lot of concepts here that observability is a tool set that allows you to communicate better. Another concept is, especially as we get into like metrics and events, there's natural events or things that a vendor provides to you, and then there's synthetic events, things that I care about explicitly. So I want to specifically look for this type of scenario or this thing, or I want to measure this value. The vendor may never had a need to tell you that information. So that doesn't exist. You have to create some other means to collect that information. So we'll also be focusing a lot on synthetic events in this context. And I touched on AI ops. Ultimately, whether it's IT service management, site reliability engineering, you prescribe to Google's Dora or other concepts, ultimately all of these things are just pieces that you ultimately can combine like Lego bricks. What is the service you're trying to deliver? Observability ultimately can end up being a practice in and of itself if your operations organization is large enough to support it. So the observability tools, as you mature, are ultimately a service to others to consume. So if I am a PACS application administrator in a healthcare situation, so PACS is medical imaging information, maybe our observability platform can give you context about your app. We don't have to understand your app. We don't have to understand the agreements or the objectives you have with delivering that app, but our observability toolset can help you to communicate that. So observability can be standalone, just we're trying to monitor what we care about more clearly, or it can be all the way to this is a dedicated practice we offer as part of our platform to any consumer of services. So let's talk a little bit about how we can apply it. So we know we have indicators and we have an objective, and those combined are something we have control over. So we start off saying, well, we know we've got metrics, events, logs. We've got to collect them. First things first, we have to figure out what are we going to collect, consume, because ultimately we're trying to get to those controls outcomes. Then we have to analyze that. So a big distinction I like to bring up here is these are two distinct phases. If you try to merge these, you lose the context. So can in time you merge these and simplify your pipeline of consuming melt? Yes. But to start, always start with raw data so that you can do analysis as a discrete step and understand exactly where information came from. Otherwise, you lose all context. Then we have to deliver that. So we've done this analysis. Maybe we're doing statistical analysis like k-means for grouping frequency analysis. Maybe we're doing simple things like, hey, what's the normal distribution of this latency on this service? There's a lot of analysis you can do, but you ultimately need a way to communicate that clearly. And we get into things like dashboards, Teams messages. Maybe it's an email report. Maybe it's a monthly report for an audit team. Maybe it's for your actual customers and you communicate it as marketing material and you say, hey, our service level objectives have been met every month this year. And once we know what we want to deliver, we can act on it. So as we think about this pipeline, we've got these components, these raw data outputs of services. We know what we're trying to control, and ultimately we're trying to find how to get between those 2 points. So today we'll show a demo using a few different technologies, all up there. So PowerShell for collection. We'll utilize Kusto, KQL, for the analysis. That's just for ease of this demo. I will caveat, Kusto is a challenging language for me to understand personally. So I totally understand if you have a different preference of maybe Splunk procedure language, maybe you use Elk and Logstash. Like there are other options, so Kusto isn't necessarily the only way. But because we'll be using Kusto for that analysis, we'll use Azure Monitor as a dashboarding tool. You could replace that with Power BI. You could replace that with any tool, ultimately, that you can communicate through. It could be an HTML web page. Doesn't have to be anything pre-bought, pre-stationary. And then we'll use Microsoft Teams as just a platform to communicate these events. So as we know what we're trying to control, we want to inform the team responsible for that. Usually if you've got your Teams group set up in a way, you can send that to an entire team of service owners that are responsible for that thing. So let's hop into this. As we go from melt to GAR control, as we look at how we can implement this, we'll talk through utilizing this in an Active Directory domain services environment. Does everyone still use Active Directory on-prem? Show of hands. Okay, yeah, okay. So this will be applicable in the sense that we're using a lot of the good practices from domain services management. So you can see things like utilizing Task Scheduler, utilizing PowerShell, running that as a group managed service account, the GMSAs, and being able to do all that so that there aren't credentials out on a server, there aren't things sitting around. Essentially, this will be the workflow that we will walk through here. So on our task, we're going to do a simple example. We're going to get all of the GPO objects, the group policy objects. So our task is going to log on as our GMSA. Our task is going to execute this commandlet that collects the information we want. It will send all of those objects into an event. So we can start to get any object from PowerShell as a custom event. And we can put that in our custom event log. So we're able to synthetically generate events for whatever information we want and is relevant to us. Phil Bossman will be doing a talk after this that goes into a lot more what you can do with Windows Event Collector, subscriptions. There's a lot you can do even without utilizing a tool like Splunk or Azure Monitor that you can do just with what's built into Windows Server. So 100%, this is just a starting point. There's a lot more interoperability you can do from here. Yep. So Kusto, like I said, it's clunky to me, so this one's going to take a few steps to walk through. I'm not the best at Kusto, so this can be more optimal. But generally, we created this event for all our group policy objects. We called it Event ID 400. We put that into our custom event log. we want to be able to, in that event log, pull out our object data. So back here, what we were writing as an event is actually a JSON, convert the PowerShell objects into JSON so that we can then consume it as string content and manipulate it in our platform. So we'll pull some information out of there, we'll make sure it's the right domain, and most notably, in this instance, what we're looking for are group policies that are disabled. So GPO status equals 0. Then a lot more manipulation because we have to modify timestamps and we have to modify the date differences, and then we have to actually get any GPO that's older than 3 days. So what we're pulling here is any disabled GPOs in our environment that haven't been modified for more than 3 days. Then we're able to summarize this, get a discrete list of these, so the distinct number of objects, by the person who owns that object. And at that point, we end up with something that we can actually present, we can report on. There's 4 different control areas, so service management domains and practices at the top there. Those are generally how we will categorize Active Directory domain services. So storing and indexing configuration information. Ultimately, Active Directory is a database. So first and foremost, you're performing database functions with Active Directory. You need to control those. Domain name systems and service lookup, ultimately DNS and being able to discover things in Active Directory are core functions. That's why things like Kerberos actually work. Central authentication and authorization, so group memberships, Kerberos, NTLM, core functionality that you get. And then user and computer configuration, so group policy objects. The one caveat I'll say here, so domain name system and service lookup and configuration management, those are 2 services that can, and in the case of configuration management, I'd encourage using a different tool. So generally speaking, because group policy objects don't give you the application validation, they don't give you any reporting capability, you lose a lot of clarity in, did my configuration management actually get applied, or is it actually in use? So caveat there. But you can see that big red one and demo domain admins, that's the result of our Custo query that we just walked through. That result of that query, too, we're able to add context of what our policy is. So our governance and our technical controls that we want to apply based on that information. So then we want to be able to act on it. And this is where observability can take sort of a next step of what are we ultimately trying to accomplish? Because alert fatigue and just blasting people with alerts is overwhelming. So there's a question of, do we even put it in a dashboard? Do we even communicate it, right? We have to understand, going back to our service levels, do we care about it before we try to communicate it? There's a lot of things we can figure out using metrics and events. There's still the question of, should we? Is there any value to communicating it? So one of the nice parts is with Azure Monitor, you can set up subscriptions so that you can actually send events into things like webhooks. And so in this example, we're just using a logic app that has an HTTP endpoint. We just say, hey, anytime this alert threshold triggers, you're going to send that message to our logic app. And in our logic app, it's just OAuth to send a Teams message. As I mentioned, there's a whole lot more you can do here. Were you going to ask a question? 100% can. And in this, I just used it to show that they're discrete steps. Okay. Yep. Yeah, so the question was, if you're already doing the collection in PowerShell, why not do the analysis in PowerShell? And in this instance, being able to have that discrete function, so do the collection and then do the analysis, that's really what I wanted to exemplify, is that collection is the raw information. We're just getting the group policy objects. That's what we're doing here. This is all we do to analyze it. And so these are all the things that you could certainly do with PowerShell. And then you could have a second event log that's your analysis log, or you could have a direct output from PowerShell that sends the report to teams. So you could do all steps in PowerShell, but you may want to have separation. You may want different teams to own different functions. Justin? Yeah, to add clarity to that too a little bit more.
Sorry, could you repeat what I
Yeah, for the camera in the back. But so Justin was mentioning that you can have different reporting software like Power BI able to analyze the same data set if you're doing that separation of steps. So you could provide the raw data to anyone to do their own analysis rather than just giving them pre-canned analysis that is only your opinion. So good addition there, good question. And the other note too is, since when you're aggregating logs for Kusto analysis using Azure Monitor, you're putting them into a log analytics workspace. That's also a more efficient way just to store information. So that's another thing to keep in mind of, am I trying to store all of this information for archival purposes and just historical reference? Am I trying to make this information available to more teams so that they can be enabled to use this data? There is that conversation too of, you don't have to collect all of your data in the exact same way. It just depends, is this something that serves a bigger purpose? So you get into conversations of like, should this all go into a data lake or yada, yada, yada. So other examples of acting on this, so you may create your cases automatically. I heard someone talking about this earlier, that they use their ticket management software and they automatically trigger tickets. So even though they send a Slack message about an incident, they still automatically create the ticket and assign it. So you're able to do a lot of integrations with these services that have APIs very seamlessly. We were actually even talking about this, of using the RAG AI models to be able to augmented generation and actually pull in context from your KB articles. So this is something even we've implemented. We've got all our ServiceNow KB articles. We use Azure OpenAI to take the context of a ticket and suggest KB articles of, hey, this looks like this issue. Maybe review this KB article before you go troubleshooting it. And trigger self-healing. Like if this is something that you know happens regularly, if it's something that you can't permanently fix, because at this point you've also got a root cause analysis and an after action reporting process where you review why this happened and what can we do to prevent it. There are things you just can't prevent, but you may have a static procedure that can fix it when it happens. And so what is ultimately your optimal management, and what are you managing? Now, I wanted to get through the deck quick, and yep, we've got 15 minutes, 20 minutes. So as part of this, since it's PowerShell conference, I wanted to provide a module that demonstrates a lot of this. So Yop did a great presentation yesterday about advanced module functions. This is bad practices, so don't follow my examples, use his. But ultimately, this is a good place if you're curious about how to start implementing synthetic events and start implementing your own observability practices. You can install this module, it's on PS Gallery, and you can run install observability, and it will generate all of this. So I'm gonna walk through this a little bit. The numeral process steps, so 1, 2, 3, 4, 5, those are the things that install observability as the function in the module actually does. And then the alpha steps, so A, B, C, D, E, those are the steps that happen after the module's been installed. So install observability will first create a task scheduler folder and an event log. So you get a custom event log where just the data you care about goes. Then it's going to make sure that you're able to get a GMSA, so a group managed service account. So you don't have to generate a password and rotate that password and manage that password on your operations server. Because there's a dependency on a KDS root key, it'll also check and see if there's a valid root key in the environment. So it'll validate that before it creates the GMSA. Then it looks through the module, and for any of the public functions that it wants to implement tasks for, it'll automatically create a scheduled task for each of those modules. So there's 4 controls this will show, and each of those controls ends up giving you a different task that will produce different information inside of each of those 4 service domains that we talked about in the KQL example. So ultimately, this is where we get to. So we had already looked at this one, which is stale group policy objects in the domain. There's also one for certificates that are registered in the root CA store. So are these things that you're distributing that are expired? So the example here of Google's, they actually replaced the cert like 20 days ago, but this was a cert that was going to expire. Service lookup. So Kerberos ticket granting ticket account is the seed for all of your authentication activity. And so good practice, rotate that seed password, and that is something that you can measure. And one last example being backups. When's the last time the domain was backed up? This is demo environment. We don't back it up often, so bad practice. That's why it's red. The nice part too, Kusto gives you a little bit more functionality. So like we can dynamically pull the domains. So if you're running these tasks in a multi-domain forest, you can automatically aggregate that information and start to parse that in your analysis and create dashboards that are applicable regardless of your domain. So, yeah, Steve.
How many users do you expect the domain admins group?
Yeah. Yeah, so the owner is demo domain admins. So what we're saying here is there is one GPO in the environment that is in a disabled state that hasn't been modified for more than 3 days. And so one GPO object is in that, meets that criteria, and domain admins is the owner. So this tells you how bad the individual or the person made it. Normally you'd want a better owner than domain admins group. But yeah, yep. And so if we look at the Kusto here, this is what we had been looking at through those slides. You can see as it all comes together, we're just generating some information, we're analyzing it, and pulling out what we need. And so looking at another example of this, like our backups. So the other thing to keep in mind too is if you're sending multiple objects, are you sending those objects aggregated as a single event? Should you do an event per object? So like with backups, there's naming contexts in Active Directory that you're ultimately making copies of. And so you're technically taking 4 backups at once. So you're backing up every naming context. So you may even have more than that. So, yep, question. So how do you prevent repeat alerts or consecutive alerts? So there are constraints you can put on the Kusto query that will trigger the alert. And so usually you'd want to filter that like, hey, in the past 72 hours. So if it's an alert that's sit for 72 hours and it's still in an invalid state, we probably want to notify again. But maybe it's something different too, where you're like, hey, we want to silence it until we know that it's resolved. So you could set a manual threshold. You could also just have the ticket come back and you could validate if this ticket is still open, then we don't want to alert again. Yep, good question. All right. So that's on the Kusto side. So on the PowerShell side, what are we actually doing? So as I mentioned too, like there's bad habits. Like when I initially start new modules, I just throw everything in try blocks just to see what breaks. So don't do that when you actually publish things. So this is beta. But in this example, so get ADDS 400. This is a public function in that module. So if we actually, here, I'll log in quick too. Awesome. Okay. So when we just run that function, we're getting custom objects that just collect information from another command. So we're just aggregating what we actually want to report on. And this is just the raw information. So this is all it would be sending in. And what we're really doing is just saying for our GPOs in our environment, we want to add additional context. We want to be able to give it our control identifier, so our internal mapping to our policy of what we care about, and then also what domain it came from. And so how that gets there is via GMSA. So if you aren't familiar with GMSAs, I'll do a really quick demo of that. So we've got on our desktop here, PS exec. We can do an interactive session as demo. And we want show. So I just logged in as a service account in this domain. To show that again, I didn't type a password. So once that's up, just hit enter on password. And now, who am I? I'm observability. So GMSAs are super powerful. So definitely, if you're trying to do this, you're trying to collect information or trying to automate anything, utilizing GMSAs just as a standard, great approach. And the nice part is, now since we've got our module, we can, let's just make sure, see if that's available. Yep. And so in this case, we just did a different control ID and we got different information. So you could run these just as a diagnostic tool. So if you've got modules in your environment that you already use to do diagnostics, to do troubleshooting, you could easily just say, hey, for those same tools, that's good information. We want to get that aggregated somewhere regularly. So like this backup, this is the backup status of the naming context I was mentioning. This is something you probably have tools that already do. You can just aggregate that through an event log. And now if you've got multiple domains, multiple forests, you're able to just aggregate that into one place rather than having to check every domain individually. So things like that, being able to aggregate that information is super powerful, even if you don't take that next step of going beyond just analysis and delivery of a report. You may just want this information to simplify troubleshooting processes. Okay. And so this install task function, essentially all we're looking at is trying to get every function in our module that would provide that contextual information and create an individual task for it that runs as our GMSA. And this is all on GitHub and PS Gallery, so if you want to review this more in depth, it's out there. Just trying to walk through it a little bit so you have some more context to why I do wonky things. And if we go task scheduler, oh, not firewall. We've got our custom folder and we've got our tasks. And so there may be things that you want to have triggered on a recurring schedule as part of preventative maintenance. Great. You could also have more advanced functionality, like you could enable auditing. So you could have auditing on NTFS, so your file system. You could have auditing on your OU structure in Active Directory. So you could create system access control lists, SACLs. Those are the corollary to DACLs. So DACLs enforce authorization, SACLs audit authorization and access. So when a SACL registers an audit event in your security event log, you could also have that trigger a task. And Phil will be talking about that as an example too, of you can use Task Scheduler to trigger tasks based on events that occur. So maybe you will want to refresh a certain diagnostic information anytime you see a specific task occur. So you can take this a whole nother layer deeper if you know what you're looking to try and consume from an event perspective. Another look. So what does this look like in the actual event viewer? Oh, I mentioned the KDS. So the KDS does do the GMSA when it installs. It does install a GMSA and it checks for the KDS. So there's two functions there. Install GMSA. If the KDS already exists, it's just going to install a new GMSA. Task scheduler, so that gives us the folder we already reviewed, and then event log. So this is the function that will actually check to see if there's an event log and then create a custom event log if there isn't one that already exists. And you can see here's where we're looking at that information. And so these are the raw events that ultimately get aggregated up to Azure Monitor in this case. As I mentioned, that could be an elk stack, that could be wrote just directly to a blob. So you could have just that raw JSON information stored somewhere. You may want that to go into Splunk. At this point, it doesn't matter because you're already in a standard format. You aren't saying, oh, I need to send this specific data to this API. You're just saying I'm normalizing this into the event log. And all of these tools already support the Windows event log. So you just have to say, look at this event log. And in this case, this also demonstrates, so for each of my naming context objects, should I have a distinct event? You may have different methodologies on how you want to consume this or report on this information. Usually, in my experience, it's just been cleaner if you keep unique objects as unique events. That way you can look for the specific information you want rather than trying to have to do like an analysis of the last 50. You can just say, hey, filter on this value of the objects rather than having to unpack every object before being able to do that. All right, and as I mentioned, so install observability is the one public function you can start with this on. And you don't even need to do that. If you don't want all the task schedulers, you don't want the GMSA functionality, you can just install the module and run those get commands and still get that diagnostic information. And the module does also have a CSV file that describes what each one of the modules does in more detail. So what domain it's in, and then those governance and technical aspects. Circling back to here though, the reason that there's 3 things in red up there, those aren't implemented. Those would be really helpful, but they aren't there yet. So just keep that in mind. So uninstalling this, you'd have to manually work all this backwards. So don't do this in production, just do this in a lab environment for now. And then also the install AZ monitor and install AZ workbook right now, they just have diagnostic text that says, hey, go make sure you did this. There's a lot to unpack on making sure, like, is this an Azure Arc enabled server? Is this an Azure server, AWS server? There's a few different components there that I just didn't have time to get implemented. So those aren't there. But on an environment that already has it installed really quick, I'll just show you what that looks like. All right. Okay. And so dash verbose is just telling you everything that it's doing in this instance. So we're calling the install event log. Hey, it's already got 10 event logs. Hey, the event log we're trying to install already exists, so we're just going to skip it. And then it's going to say, oh, well, we're also registering a new log source. So if you haven't done all these steps before, this is also a good reference point of like, how can I do these individual things? So even if you don't want to run this in production, you could still look at these private functions and just analyze what is being done there. Log source already exists, so we don't need to do it. Then we're installing the task scheduler folder. Then we're looking for, it already exists. We're validating the module dependency because we're looking at AD. We're using the Active Directory module as a dependency. We're running the GMSA. It finds the KDS root keys, so it doesn't see anything it needs to do there. It found the GMSA account. A note here too, if you're playing with GMSAs, GMSA credentials do get cached locally on a machine. So if you've run any GMSA account on a machine and you say delete that GMSA from Active Directory and then recreate a GMSA with the exact same name, those SIDs are going to be different, so they won't be able to authenticate, but Windows for some reason still thinks that that's the right account, so it's going to try to use that cache credential. So you have to go into HKLM and the security and actually delete that cached GMSA account. So weird nuance there, but if you run into that, happy to help. And then it's looking at the objects and saying, hey, these already exist, so no need to make them. And then as I was mentioning, last but not least, if you want to do this in like a hybrid environment, you need Arc. If you're unfamiliar with Arc, it's Microsoft Azure's extensibility for hybrid multi-cloud scenarios. Super powerful. One of my favorite things about Arc, you install it, no cost, register a machine with Azure. Now that machine can be a managed identity. So you can use that machine to just go connect mggraph, connect AZ account, dash identity. It'll log into those service APIs as the machine identity. So just like you're using GMSAs on-prem with your Active Directory, you can use managed service accounts with any of the Graph APIs or ARM API endpoints. Super powerful, super awesome. The Azure Monitor Agent is an extension either in Windows or an extension via Arc that lets you collect event logs. And in Azure Monitor, the collection rule is basically just targeting our one event log. You could expand that, but if you're cost conscious, make sure you scope what you're looking at, just so you limit how much information you're collecting and ingesting and ultimately being charged for via Azure. All right, that was a lot. We're just about at time. Any other questions? Yeah? Yeah, so when you authorize a server via Azure Arc or Azure with a managed identity, and it has access to Graph API or ARM API endpoints, does anyone logging into that server have access to it? Yes, 100%. Anyone who can technically run on that machine as an administrator can get an active token against those APIs. So yeah, you have authorization within Azure on the service principal objects to restrict that. And then you also have authorization who can access Windows and log into Windows to restrict that too. But it is a good call out. In architecture, we'll often see is development environments. So instead of making someone do like a device code authentication every time they want to use the Graph API, give them a development box, make them securely authenticate into that development box session via Bastion or some other session management product. And so once I'm MFA'd and I'm RDP'd into that session, let me run as identity, and you know that that identity, that development box is associated with me as an individual. So that can be a way to make your developer experience or your admin experience a little bit smoother of like, hey, we're adding a lot more security, but we don't want to add a ton of friction every single time you're logging into a new session. We're only doing it to the RDP session rather than every command you run. Other questions? Yeah. Yeah, so does the named event source or the named event log show up in AMA, Azure Monitor? Yes. So you can filter, if you've got the custom event, you can filter using the XPath query to say just this event log, or you could say, I'm only using this event source, only look for events in these event logs with this event source. So you don't have to use a custom event if you don't want to, or event log. You can just use a custom event source if you're already ingesting information from a event log file already. Good question. Okay, so super quick. That's who I am. That's what I like to talk about. So always happy. Feel free to reach out, talk to me around here, talk to me anytime. Thank you to our sponsors. Oh, you want a picture? Go for it. Yeah, I think we're at time, so I just am wrapping quick. But thank you to the sponsors. And then just a quick recap. This is what we walked through and demonstrated. So yeah, thank you all.